Hello again, I'm Sajjad Rabi, and finally welcome to the last part of PyroFX in Houdini 18.5 for beginners. In this part, I'm going to talk about fire and smoke simulation. At the beginning, I will show you a very simple way for simulating fire, which is useful, for example, for campfire. I will talk about some tips and tricks about shading, how you can improve the look of your fire, how you can make it more realistic at the render time, or even how you can add some extra details to your fire with shading without any need to have a very high resolution of the pyro simulation. I will talk about fire simulation with moving objects, something like torch, and I will show you a very simple setup for spreading fire. On that part, we are going to create this project from the scratch. And I will talk about the smoke simulation, and I will show you a very simple way which helps you to have better interaction between moving collision objects and smoke simulation. At the end of this tutorial, I will show you my setup for these projects, how you can simulate fire, for example, for this skull project, or for this fire trover, or fire and smoke simulation for this special project. About fire simulation, there are some difference between fire and explosion. For example, in fire, we don't have any expansion. In fire, we are dealing with low density smoke, or sometimes we don't have any smoke simulation at all. Usually with fire, we are dealing with turbulence more than disturbance, because what we are looking inside the fire is some large-scale turbulence noise rather than very small details which we need for explosion. And also, because we don't have gas expansion in fire, the shape of the fire is following the shape of your source more than explosion, especially because all of the things are happening somewhere close to your source. So if you want to have some special type of the fire simulation, maybe you need to play more with your source, with its velocity, its shape, more than explosion. I believe for simulating and rendering realistic fire, the shading part is very important, and sometimes it's much more important than fire simulation itself. I know there are some of artists that they are not happy about their result regardless how perfect simulation they have, and in most of the cases their problem comes from the shading part, not the simulation part. So in this tutorial I will show you some little tips and tricks about shading part, how you can improve the look of your fire and how you can make it more realistic. So let's jump inside the Houdini and start the first part. Okay, at the beginning, in the very simple setup, I just want to show you what's the right procedure of the simulating fire as well as shading. And later on we are going to build a little more complicated fire simulation. Okay, I'm going to use Pyro configure GPU explosion. I really like this setup because you can do everything with this simple setup. If you want to simulate with your GPU, it's already done. If you want to simulate it with CPU, you need just to turn off this option here. It's already done for explosion. If you want to simulate fire or smoke, you need just to do some little tweak inside your network. Okay, for our first fire, I'm going to use a very simple source, something like Taurus. That's fine. We need to have some deformation on it because we need to have velocity data. Velocity data from the source is giving you better look after simulating the fire. So here is mountain sub, and I'm going to use $t multiplied by 10. We have some motion, and of course I'm going to use trail sub to generate some velocity. Central difference, here we have velocity. In the next part we need to create those attributes for pyro simulation. As I said, in the case of the fire, at least we need to have burn and temperature, and burn is going to be used as a source of the fire. So I'm going to drop down pyro source node. I want to have burn and of course temperature. If you want to scatter some more points on the torus, you need just to change the mode to keep surface. Sorry, to surface scatter. And probably more points. We have temperature, velocity, and burn, and it's time to convert them to VDB. So another version of attribute rasterize, volume rasterize attribute, sorry. And here we have burn temperature and velocity VDB, and just inject it to your Pyro Solver. As I'm going to use my GPU, in the sourcing tab, you need to change the source frame range. I want to inject my sources from frame 1 to 50. Density is not useful. We have just burn and temperature. Let's see what we have. Okay. It looks like explosion. We need to do some change inside of the Pyro Solver. At the first step in the flames, you need to turn off expansion because we don't have any expansion for fire simulation. And you can turn off smoke as well if your fire doesn't need to have any smoke, but I suggest you to use this option here because later on in the shading, if you have density data, it's much easier for you to play with your fire. If you want to remove your smoke, you can do this in your shader, not at this point. Okay, and our smoke is so dense. Let's play with look tab for now and decrease intensity of the fire because I couldn't see the details of the fire. I'm going to use 5. Okay, in the next step we need to work on the details in the solving, in the shape. As I said, for fire usually it's better to work with turbulence rather than just disturbance. We can leave it as it is. Just let me turn on turbulence with more turbulence, and of course I don't need to use density as a mask of the turbulence. I want to have same amount of the turbulence for my entire simulation. If you want to change these parameters during the simulation times to see how are affecting your simulation, you can just turn on this option here, live parameter display, and after that, by changing these parameters, you can see its result in the viewport immediately. I think 1 should be fine, and maybe we need to extend our container size along Y. Let's try 20, 7, or 10. Is it good? No. 9. Okay, we have something like fire. Let's jump to the next part, which is shading, because for adding some extra details to your fire, there is no need to just play with the turbulence and disturbance inside the Pyro Solver, or even decreasing the voxel size. You can add lots of details in the shading part as well. So I'm going to the next part. We need to have Pyro Bake volume. That's good. And of course, don't forget to convert them to VDBs. It's much faster. And here I need to play with the Pyro shader material inside the Pyro bake volume. I'm going to break all of the connections of the shading from these parameters. It is much easier for me to work in the IPR mode and just change these parameters with shader itself. Let me append mantra node, fire, and a camera. Okay, something like this, and do a test render. Okay, in the Pyro bake volume, Pyro shader, you need to turn fire. For rendering fire, we are not going to use the scatter part. The scatter part is useful when you are dealing with the explosion, but for fire itself, we need just to play with the fire part. As you see, the result is not so realistic. We don't have any details, and I'm going to show you a very simple trick which makes your look so better and probably more realistic result. In the intensity, currently we are going some constant number as an intensity of whole fire. You need to change it to use ramp, and here is the value of the intensity for the hottest point on your simulation, and here is the value for cooler parts of your simulation. The little trick is about playing with this fire intensity ramp here. You need to set this point value to 0 and add another point somewhere here. 2 more points. Press render. Select these 3 points by holding shift key and move them until you're getting good result of the fire. And overall intensity is so high, let's decrease it to 7. And for now, I don't need to use smoke, just fire. As you see, we have very better result just by adding these points to our ramp. I think it's good for now. And I want to add a little something like glow effects in around of the fire. For doing that, you need just to add a very small number to the value of this point. For example, 0.1. As you see, we have some low intensity fire around the core, which is giving you better result. Okay, our fire is so high, we need to change the lifespan of the flame. In the solving the flame, you can decrease the flame lifespan, and of course you can play with buoyancy as well. I think in this case playing with buoyancy is better solution. Let me decrease it by half. Okay, much better. Okay, as you see, we have a very better result with a very good details at the render time, even with very low amount of the voxels. I just left it with 0.1. You would have a little more details by using lower voxel size. Let me decrease it to 0.7 or even 5. Do another test render. Oops, sorry, 0.05. Okay, that's good. One thing is so important about rendering the fire is using motion blur. It's much more important than using motion blur in the explosion. I need to have velocity data. Currently, with a Minima Solver, we don't have any velocity data, so I need to open this digital asset, dive inside, and connect the Pyro post process to this node. And now we have velocity. You can merge all of the velocity data to one single vector VDB field. It would be much faster. VDB vector merge. And here we go. We have one vector velocity field. And in the rendering part, in the sampling, you need to change this option to velocity blur, and don't forget to turn on velocity in your mantra node. Let's do a test render. Okay, that's much better. It was a very simple procedure for simulating fire as well as shading. Now let me work more on this fire. Now I want to simulate a fire for torch. Let me make a simple setup for it. I'm going to use sphere and tube. 4 as a height. Let's reduce scale. Okay, same for sphere. We need mountain sub. I can just use these nodes here. You can add velocity by using, for example, point velocity node and using the curl nodes as well. Or you can just try to generate velocity based on deformation. Make a group for sphere itself because we need to just use sphere as a source of the Pyro Solver. And split sphere and connect Pyro source to sphere. Okay, let me create some simple animation for torch. Just very simple. Set keyframe. Okay, something like this. You need to use trail sub after transform because we need to have velocity based on this animation as well, not just deformation. And let's see what we would have. Just for now, I'm going to increase voxel size and change the sourcing range to 100 and cycle length to 240. Okay, we need to increase flame lifespan because the fire is so short. I'm going to use 2 or maybe more. Good, let's do a test render. For example, frame 39. it's better to set your render flag to the null, because sometimes you might forget to set your display and render flag to the end of your network, and the mantra node is going to render your project at this point. So by pressing Ctrl key and click on this guy, you're going to set your render flag to this null. Not too bad. I think we need to decrease the voxel size, and be careful about the container size as well, because now we have some animated object. I'm going to use a simple box, and here is our torch, increasing the size. Okay, that should be fine. Connect size to max size and center to the center. And I'm going to decrease voxel size to 0.05. We were at frame 39. Oops. Okay, that's good. And also I need to increase the pixel samples. We have some noises on this area in the mantra node. Usually 6 and 6 should be fine. That's good. Let's check another frame. Frame 60. 77. Let me change the camera view. Okay. Okay, that's good. And also sometimes you can increase the value of this point to something more than 1. So let me try 1.5 or 2. It's giving you very shiny parts, very high intensity parts inside your fire. For example, in this area, and the details are more visible. And to change the shape of your simulation, you can play more with disturbance and turbulence, and also don't forget to play with velocity here as well, because for now we have some animation in our torch, and the velocity data here is more effective on your simulation. Just for doing a test, let me decrease it to 0.25. Oh, we need to extend our container size more along y-axis. That's good. If you want to render your project with the geometry of the torch, I think we don't need to use mountain, because I was using this mountain only for generating some noise on the velocity. Okay, and now out torch, fire, another geometry network for torch. object merge, and point it to the geometry of the torch inside the fire network. You can render the torch beside of the fire with assigning some material, and also if you want to render your fire in separate XR file without torch, don't forget to use torch as a mask or mat of the fire. So in the mantra node objects, I'm going to set force object to fire and force mat to torch. And now we have torch as a mat object inside the fire simulation. For simulating fire of the torch, we are usually using some smoke as well. In the fire shader, I'm going to turn on enable smoke parameter. It's so bright. I'm going to decrease smoke brightness. Okay, that's better. In the fire tab, you need to play with masking part as well. Usually it's giving you better result. Of course, our smoke is so dense now. Okay, in the fire, I'm going to increase mask center to something like 0.75. Play more with the smoke density. Okay, now we have smoke and fire. Probably more intensity for fire. Okay, let me do a test render from this project. Of course, I want to render it just without smoke because of the render time. I don't want to use the smoke and the masking part. I just want to show you how the fire is moving at the render time. So I'm going to disable enable mask here and turn off smoke, at least for my test render. Let me play more with this RAM. Okay, that's good. In the mantra node, our frame range would be 1 and 100. Camera is cam 1 and do a test render. And don't forget to set your output picture somewhere on your disk. Okay guys, my render is done and I think the result is good, but we have few issues on this simulation. The one is so obvious is we have lots of turbulence noise probably on the fire, and also the motion of the fire on the source, it's not so good as you see. Probably we need to use the geometry of the source as a collision object as well. So I'm going to do some changes inside my network to fix these issues. Come back to the fire simulation And here I want to use just this sphere as a source of collision object. Okay, and VDB from polygons. Change the name to collision and turn on fill interior. Connect it to the second input of the Pyro Solver, and the collision object source range should be same as the source, 1 to 100. And also, I think some of these turbulence noise are come from the source. I'm going to decrease the height of the mountain to some smaller number, and let's see what we have. Okay, that's much better. Now we have some collision between the source and fire. Let me turn on this option here. And probably we need to increase velocity of the source. Okay, that's much better, but we have some stepping issues on this area. One here, another one, another one. Look. To fix this issue, we can use more sub-step for entire simulation, but unfortunately when you are working with the minimal OpenCL solve, it's not possible to increase this option. Usually it's giving you some artifact inside your simulation. And another option which we have is here, increasing max substeps. It's not going to increase substep for entire dynamic network, but just the Pyro Solver inside your DOP network here. But with minimal OpenCL solve, when this stepping issue comes from the collision object, it's not going to be solved with this max substeps method. But if your stepping issue comes from the source, you can increase the max substep and you shouldn't have any stepping issues anymore. I will show you this one on my next project. But for now, because this stepping issue comes from the collision object, it's not possible to increase this substep. If I am going to, for example, set it to 4, I would have some stepping issues again, as you see, because it's for collision object. In this case, I must turn off the minimal OpenCL solve for this special setup for the torch. And now, by increasing max substeps, you shouldn't have any stepping issue. As you see, those stepping artifacts are entirely removed. Maybe 4 is so high. Let me decrease it to 2. Okay, we have a little stepping artifact. Let's try 3. I think 3 is good. And do a flip book. Let me turn it back to 4. Okay, flip book is done, and we have much better motion on the fire. We have good interaction between collision object and the fire as well. And it's time to do another test render. Just before doing that, I want to make sure my shading is working with these new parameters. So I'm going to frame, for example, 30. Okay. Let me play more with this ramp. Maybe something like this. And also, I am going to increase turbulence a little more. And I think that should be fine. Let me render a few frames of this simulation and I will be back soon. Here is my render. After watching my result, I find out that the turbulence is so high on the fire, especially at the end of the simulation. You can see we have lots of turbulence. So I did another version with using less turbulence. I've used 1 as a turbulence, and here is my other version. It is a little better than previous version, but still we have lots of turbulence at the end of the simulation. So I did another one with using 1.5 as a turbulence, and also I've used density as a control field. And the last version is much better than the other 2 versions. As you see, it's giving me better look or better shape of the fire. So in this setup, I will keep going with the density as a control field of the turbulence noise. Okay, I think that's enough for simulating fire for torch. Also, I need to mention that I wanted to keep this setup so simple for you, but to get better result, you have to play more with the parameters or even working with the other gas micro solvers to control exact shape of the fire and the details of the simulation. Inside the compositing software, in this case I'm working with the Nuke, you can do few things to make your fire more interesting, and also you can make your details more visible with some few nodes inside the Nuke. Here I did a very simple setup inside the Nuke. Here I have my footage, and here is my final result. As you see, I've worked on the details inside the fire, especially in the hottest area. And what I did is using hue shift node to push the colors a little more toward the yellow, and in the color correction node I was working with the highlight area and also changing the shape of the curves for highlight and the shadow. So by controlling the gain of the highlight, we could add more brightness to the highlight area of the fire. And I was working a little bit with the midtones as well, and shadow, maybe a little more darker. And I've increased the overall gain of the footage. And also you can use sharpen node in the comp, but be careful about the sharpen, because if you are going to use very crazy value as a size, your result will be worse. And in this case, I was using 1 as a size just to make it a little more sharper. Of course, my render size is just 1280. That's why it's a little blur. And I've used a couple of glow node, same as what I did on my explosion setup from part 1 of this tutorial. And here we have a little more glow and final result. Okay, we are done here. In the next part, I am going to show you a very simple way for simulating spreading fire on the ground. Okay, let's keep going with spreading fire setup. I will use my setup from the Torch project. Just we don't need to use these nodes because they were for Torch project. For this project, I want to use a free 3D scanned model from this site, 3dscans.com. If you go down, you would find a 3D scanned model of the skeleton. It is a guy who was starving, I think, or something. Just download this model and open it inside the Houdini with file. It is so big, so scale it down with transform sub, maybe 1.01. Okay, that should be fine. In the next step, you need to scatter some points on it. With scatter sub, we have scattered points, increase number of the points. Okay, that's good. Now, create sphere. My fire will be spreading from this point, so put this sphere here. Okay, and append a group. I want to put all of the points which are inside the sphere into this group. Let's call it, for example, start fire or something. The type should be points. Turn out this option and using bounding region, set it to bounding object. That's good. Create a color. Make the color of all of the points to black and change the color of the points which are inside the group to white. That's good. Let me change the color of the background to light because the black points are not visible, and maybe increase the size of the points inside the viewport. I'm going to change the type to points and change the point size. What I want to do is creating a growing effect on these points. I mean, I want to do something which allow me by pressing play button, the white area growing more and more through the entire model. Most of you should be familiar with this method with solver sub. For doing that, we need to search around of each point and find the list of all closest points to the current point. For example, suppose I'm talking about this point here. We need to search around this point based on certain radius and find the list of the points, the closest points. And add the color of near points to the current color of this guy here. For example, in the next frame, suppose we find this point which is close to this point. Because the color of both are black, black plus black is black. But we would find this point as well. The color of this point is white. White plus black is white. So the color of this point is going to be white in the next frame. And in the second frame, this point is white already, and we are talking about the next one. The color of these points are black. Black plus black is black, but this point would be white on the first frame. So in the second frame, the color of this point is going to be white as well, because white plus black is white. And because of that, when we are pressing play button during the animation, this white area should be growing more and more and covering entire area of the scattered points or geometry. For doing that, you need to work with Solver sub. What the Solver sub is doing is letting you to use or accumulate the data from the previous frame to the current frame. And that's the main big difference between dynamic network and the regular geometry network. Inside the geometry network, the nodes are cooking one by one from the top to the bottom, and it's done. In the next frame, it's going to cook your first node again and going through the end of your graph. But inside the dynamic network, it's working like something like the looping systems. Your network is cooking from the top to the bottom, but at the end of the network, your data could be turned back to your input, and you can use those data inside the next frame for doing some kind of the operation. And actually, the solver sub is some kind of the dynamic network as well. If you unlock it and dive inside it, you can see that we have dynamic network here, and all of the operations are doing inside the dynamic network. Here you have access to the data from the previous frame, and here is your data from the current frame. So in this project, we need to work with solver sub. I'm going inside it and just drop down a wrangle node. We need to find the nearest points to the current point. For doing that, we have a couple of options. You can use the near points function as well. Let me open the help page. And also you can play with point clouds, but near points function is faster than point cloud. To work with this function, you have a couple of methods. And in the very simple one, you need to define your geometry, which is the data from the first input of the attribute wrangle in this case. You need to define the current position, which is @p, and also your search radius or max distance. And this function is giving you the list of all of the nearest points inside the array. But in this project, I'm going to use the second one, because in the second one, we have some limitation number here, the max points, which allow you to find only a certain number of the nearest points. And because of that, your simulation would be much faster. Just suppose in some cases you might have, for example, million or 1,000 numbers of points which are inside this max distance and which are close to your points. But we could limit those numbers to something like 10 or 100, and your overall operation would be much faster. So I'm going to use the second one. Okay, the output of the near points is the array of integer numbers. Because it's the point number, I'm going to use int and create array variable. Let's call it PTS, for example, equal near points. The geometry is the data from the first input, so it should be 0. PT is at sign P, the current position, and max distance, let's try 0.1, and maximum number of points could be 100. Now we have our array. You can test it by adding some point attribute. Let's call it, for example, JK is equal PTS, and the type should be array. If you're opening a spreadsheet, you should see that. Oh, let me quick the solver sub again. Oh, I forgot to connect it to the color too. And here we have the list of all of the 100 points which are inside this max distance based on this position. So it's working. Now we need to create a loop. I'm going to use for each loop. It is much easier for this project. Create integer number pt and semicolon pts. Inside this for each loop, based on each iteration, we have the 1 point number from one of the nearest points to this current position inside the pt. As you remember, we wanted to read the color of the near point, so I'm going to create a vector variable. Let's call it cd2. It's equal point function, because I want to read color which are saved on the points, not primitives. The data from the first input, the attribute name is cd, and the number of point is pt, not at sign pt num, because we want to read the color of the near points, not the current points. Okay, and in the next stage I'm going to add this number to the color of the current point. So cd equal plus cd2. Let's check it. It should be work, but we would have a problem here. Okay, it's working, but our points are going to be black after a certain time. That's because if you are just open spreadsheet and check your cd, we have some huge number as a color, or infinity in this case. That's because, for example, in the first frame, this point is white, so the color should be 1, right? But in the next frame, we have some white points close to this point, and we are adding the number of those points to this point as well. So 1 plus 1 plus 1 plus 1, it could be some large number, and after a certain time, this number is going to be so huge and even infinite number. To fix this issue, you can simply just use the clamp function to clamp your color between 0 and 1. I'm going to use cd equal clamp cd 1, 0, and 1. And that's it. We have some nice spreading effect or growing effect over my geometry. There is another little trick if you want to make this effect more interesting. For now, we have some straight line or a circle shaped line on the white, at the edge of the white area. We can add some noise to this edge to make it more interesting. Inside the solver sub, you need to add some noise to this position here. Usually, for working with the noises inside the Houdini, I'm more happy to work with the VAP nodes, or for example point VAP in this case, rather than writing noise function inside the Vex. I think working with noise inside the point VAP, it's much easier and simpler than the attribute wrangle. So let's do that. I want to call it add noise, and inside it you need to append anti-alias noise, position to position. The type should be vector because we want to add this 3D noise to the position of the points. But instead of using the output to the actual position of the points, I'm going to create another attribute because we need to keep all of the points at what they are, and we don't want to change the overall shape of the points. So instead of this method, I'm going to create attribute with bind export. The type should be vector, and let's call it p noise. And here, instead of actual position of the points, I would say that use p noise, and don't forget to use this type here. It should be vector. And let's check it again. Okay, it's working somehow, but it's not growing anymore. That's because after this displacement, some of the points are going so far from the or current point. If you check the actual position, as you see, we have some huge number of displacement. To fix this issue, you can just do a simple trick here, promote offset parameter of the noise and use $t. So we would have different shape of the noise based on each frame, and it's giving us better result as well. You have some other methods for adding this growing effect rather than working with the colors. For example, we had a group here, start group. You can search for all of the near points to the current points and put those points inside this group as well. But I find out that, for example, working with set point group function is heavier and slower than working with this method. So usually I'm using these simple codes when I need to have something like growing effect. But there is something you can do to make your simulation a little more faster. Currently, our VEX code is executing over all of the points, even the points which are white already. We don't need to run this code over the white points because we need just to change the color of the black points. What you can do is create a group for the black points and tell this wrangle to run this code over those black points. So let's do that. Here I'm going to create a group expression. The name could be black. The type should be points, and I'm going to tell it if the red value of the points is smaller than certain number, put it inside the group. So we have special group only for black points. Inside the solver, we need to set the group to black. So this code is executing only on the black points, but it's not working yet. If you check the output, for example, I'm going to create another color, make them red and use the black. You can see that our group is constant or static. It's not growing over the simulation. That's because on each frame we have some new white points and we need to remove those points from this group. So you need just copy this node here and paste it after this wrangle and check it again. Now our group is growing as well, and especially at the end of the simulation time should be much faster because we have less black points on the geometry. Of course, because we are using very few points here, it's not so visible, but if you increase the number of points from the scatter, you should see that significant difference between using this group or running your code over all of the points. Okay, I think that's okay, and we're done here. Let's go to the next part. We need to use the white points as a source of our fire simulation. Let's keep the white points. I'm going to tell it remove black points and connect the points to your pyro source. So we would have temperature and burn attribute. And don't forget to change the mode to keep input, because we don't have any surface and we need to use the input points as a source of our pyro source. Okay, that's fine. Here we have the VDB data, and let's see what we have in after Pyro Solver. And I'm going to use a minimal OpenCL solve because I don't have any collision object or animated collision object actually. And in the sourcing part, our frame range is 240. Just for test, let me increase voxel size to some larger number. Okay, it's not working. Probably that's because of the size of the container. We need to increase the size of the box. Here it's our actual geometry. Just extend it like this. Okay. That should work. And check it again. Now we have some nice fire which is growing over our geometry. To make it more better, you need to use this geometry as a source of collision object. So VDB from polygons and turn on fill interior, change the name to collision and connect it to second input of your Pyro Solver, and don't forget to set collision from range to 1 because for now we don't have any animated object as a collision object. Okay, that's better. Let's do some test render and see how the fire is looking at in the render time. Okay, I think that's good. Before doing some test render, if you wanted to increase the speed of this growing, for example, at the end of the timeline, some part of the object are remained black. You can play with max radius here, or even you can use some retiming to increase the speed of your growing. But in this case, I think that's fine. I'm going to frame, for example, 120. Change the position of the camera. Before pressing render button, don't forget to introduce this object as a source of math object. So let's call it out matte, and here we have torch, change its name to skeleton, and out matte. Okay, it's looking good, but I'm not so happy about this low intensity fire on the surface. As you see, I want to do something to remove this low intensity fire area. Usually we would have less velocity at this area because we don't have any turbulence at the beginning of the simulation. We can play with the velocity and use its speed as a to control the overall temperature, because in Pyro shader we are using temperature as a source of the fire. Here you need to drop down volume VAP, and inside it we need to compute speed of the velocity field or length of the velocity field. Bind, I want to read vel. Do we have any velocity? Yes, it's already done. And here the type should be vector. I'm going to compute length of the velocity field. So here we have speed, use a fit range to control the output range values, and we need to read temperature. The type is float, temperature, and bind export to export our new temperature field, and multiply first input, second input, and output. Okay, the source min and source max is our minimum speed and maximum speed. Let's change the source min and max min to something like 5 and 7. As you can see, we have less fire on the slower part of the simulation, and that should fix our problem. Let's check it. Here is our previous frame and the new one. Okay, new one is much better. Of course, we need to play with this RAM shape here because I did this for the torch project. Let's get rid of it for now. Okay. Add some more, a little more density to this area. I think that's good, but we need to increase the number of voxels. So here I'm going to use, for example, 0.04. As you see, minimal OpenCSO is really fast. Okay, we have better details, but our simulation is stopping here. Let me check few things. That's correct. Maybe I was rendering at a different frame. And check the last frame. Okay. Render again. And here we go. Maybe would be better if we increase the speed of the growing here. I don't want to use interpolation between the frames. Usually it's useful when you are dealing with slow motion. And speed it up by maybe 2. Okay, I need to increase the input frame range to something more. Maybe it's so fast. Okay, that's good. Let's keep going with this retiming. I want to make it a little more faster. Okay, not too bad. Now I want to do a simple setup for lighting and rendering. Before doing that, let me cache out my simulation to the disk. I'm going to decrease voxel size a little more. Based on my GPU memory, I think I can go below that 0.03 or even 25. Let's try 275. And file cache, just if you remember, for caching out the minima solver, I said you might have some problem with the very last frames of your simulation if you are going to use the save to disk button. Because of that, usually I'm going to set the file mode to the right and just play my timeline to save each frame of the simulation directly to the disk. Sometimes with very heavy simulation, I'm facing with some issues when writing each frame to the disk. And also we need to have velocity as well. Okay, it's done here, but because your file is going to be so large on the disk, it's better to compress your velocity field. And just use 16-bit float. And okay. Also, we don't need to have very low voxel size for velocity. So volume, resample. Of course, we can convert it to VDB and use VDB resample here. And let's store just with 0.5 as a resolution scale. I think that should be fine. And just let me save the simulation to the disk, and I will be back soon. The simulation is done, and that should be fine. Now I want to start the lighting and shading part, and we don't need to use spotlight 2, just spotlight 1. Let me change its position to somewhere like here, maybe with more exposure. And also we need to add some simple motion to the camera. About the camera, I want to do something to let the camera always looking at the skeleton. For doing that, I want to use a constraint here, the constraint option. Before to use that, I need to create a simple null, and here just click on this button here, choose look at, select your null one, and somewhere in empty space on the viewport, press enter. What this option is doing is creating a chop network inside the camera, and use this look at node to compute the rotation of the camera based on your look at point. So the rotation here is not useful anymore because the actual rotation of the camera is reading from the look at node here. If you move your camera, you can see that it's always looking to your look at point. I'm going to change the position of the null to somewhere like this. Maybe move it up. It should be better. Okay, just for a sec, let me turn off the fire here because it's so slow in the viewport. In the first frame, I'm going to put the camera here, and maybe here, set keyframe. In the last frame, here. So we have very nice motion of the camera, and also you can set keyframe for look at point here as well. For example, at the first frame, 8 for the last frame, and in the middle of your timeline, it could be here. Okay, that's good. Also, we need to have a ground object. I want to use simple grid with more uniform scale. We need to have a material for a skeleton and the grid in the matte network. Principal shader. I'm going to remove reflection. Just set reflectivity to 0. I don't want to have any specular or reflection on my objects. Maybe with less albedo multiplier, and assign it to grid and skeleton. In the out network, for now, I want to render skeleton and the ground as a simple object, not matte object, because I want to see them how they are looking at the render time. But later on, we need to create another mantra node. With one of them, we need to render fire with using skeleton and the grid as a matte object. And with another mantra node, we need to render our environment separately in different XR file, because with this method, we have more control on them inside the Nuke software. So grid and skeleton, let's see what we have. Okay, we definitely need to decrease intensity of the spotlight and add some bluish color. Maybe like this. If you want to use soft shadow for your light source, you need to change its type to sphere and increase area size. Let's try 10 and 10. Now we have a nice soft shadow here. The next step, I want to generate some volume light based on the fire. For doing that, we have volume light in Houdini. Just click on volume light, select your fire and press enter on the viewport. Now we have volume light. Okay, it's working, but the intensity is so low. You need to increase intensity. Let's try 10 and maybe a little more exposure. We have a nice firelight on the ground. If you want to decrease the noise on your volume light, you can increase sampling quality. And sometimes if your fire is not so big and it's close to some object, or it's close to your ground, you need to increase the point samples as well. With using more point samples, the volume light is following more the exact shape of the fire simulation. But in this case, because we have a very large scale fire, we can keep going with very low point samples, maybe 16 or 32. Because with using a higher number of point samples, your render time is going to be longer. The skeleton model is looking a little dark. For now, let me turn off the volume light and also remove fire here. Okay, it's looking completely dark. Okay, we add some black color already to the points. I need to remove that CD attribute. Okay, it's looking better now. And turn on volume light again and add fire here. I would like to increase intensity of volume light again. And don't forget to render your light as a separate AOV because of the compositing. So in the image, extra image planes, add new extra image plane and use combined lighting per light. Now we have volume light and spotlight as a separate path. I think we need to use some darker color, especially for skeleton, not the grid. So instead of attribute delete, I'm going to use color. Let me check it. Okay, that's better. It looks so dark for spotlight. Yup. Okay, that's good. As I said, we need to render fire and environment in the separate XR file. I'm going to create a copy of this mantra node here, call it environment, and here is fire. In the fire, you must use skeleton and grunt as a mat object. And here we need just to render environment. The spotlight and volume light paths are not useful for fire because it's volume, but they should be useful for environment. Because we are going to render environment and the fire as a separate XR files inside the compositing, it's so easy for us to tweak the light separately there. And now everything is ready, and let me render this project for 240 frames. Okay, I rendered this project already, and the compositing part is pretty simple. Here we have fire and environment. In the fire part, I've used same techniques which I told you in the previous lesson to add some more details to your fire inside the Nuke, change its color, and use the highlight area and the fire, couple of glow nodes, and here is the result. In this part we have environment. I extracted the spotlight path and the volume light path with the shuffle node, volume light, and here we have spotlight 1. Do a simple color correction on the spotlight path and same for the volume light. And also I've used denoise node inside the Nuke to decrease the noise of the volume path a little bit. And merge them together. We have environment path, again couple of glow nodes, and denoise again, and merge it to the fire. Okay, I think that's enough for this project. Let's go to the last part. If you want to simulate just smoke without any fire, it's so simple. I think I told you this before. Here, for example, I have a very simple sphere with a 3 as a frequency, simple mountain node with some motion on it, and compute velocity here. We have pyro source volume, and for smoke we need just to have density and temperature, and also velocity is producing by trail node. We have density, temperature, and V. And here we have a simple truss as a collision object converted to VDB with the name of collision and connected to the second input of the Pyro Solver. My source frame range could be 1 and, for example, 240, and same for cycle length. Okay, the smoke is so dark. I'm going to increase smoke color. Maybe less density scale. Of course, it's just about how you can control your smoke in the viewport, not render time. Okay, we have lots of this disturbance in the shape. I want to use 10 and also use the speed field as a control field of the disturbance. And we need to have turbulence as well. Okay, that looks good. Change the size of your container. And more voxels. Set voxel size to smaller number. Let's try 0.075. Okay, that's a simple procedure for simulating just smoke. If you want to do something to let the smoke goes up here, you can play with, for example, dissipation, maybe less dissipation. And to control the speed of the smoke, you can play with buoyancy scale. For example, it should goes up faster. Or slower. Same project, just with animated torus as a collision object. And there is a simple trick about dealing with animated collision objects when you are working with Pyro Solver. If you want to have more interaction between the motion of the fire and the motion of the collision object, like what we have here, you can produce velocity data based on your collision object. Here is my animated torus. We have trail sub to generate velocity. Then I used Pyro source to scatter some points on the torus and transfer velocity data from the torus to those points. We have velocity. I've used volume rasterization node to convert velocity attribute to V field or VVDB. And I've changed the name of the V to V2. Then you can inject this V2 field as a source of your Pyro Solver, and later on add this V2 to your current velocity data inside the Pyro Solver. So here we have V2, here we have V, temperature and density. We have all of them. In the Pyro Solver, in the sourcing pod, I add a new vector source. The name is V2, and it should be work on the velocity field inside the Pyro Solver and set the operation to add and use very small number as a scale. Just let me increase voxel size. Okay, here is the result without any velocity data from the collision object. As you see, we have a little interaction between the torus and the smoke, but I wanted to increase this interaction. So with this method, I've got this result. For example, here we have more interaction based on the rotation of the torus. In frame 127 and without using the velocity of the source. Okay, I just wanted to mention this simple trick to you about dealing with animated collision object and your Pyro Solver. Now let's have a look to some of the fire projects which I did for these tutorials. The first one is Fire Solver. Its setup is so simple. Let me show you. We have single point here, and after this copy node, we would have 1000 different points at the exactly same position. So we are going to use them as a source of the pyro bursts. Here we would have 1000 different pyro bursts, but not all of them are happening at the exactly same frame, because in the burst animation I was using very high number as a variation. Because of that, on each frame we have just few of those burst points. In this side we have simple tube, poly extrude, simple animation on it. I've used exactly the same transformation for these points to have same motion, and convert the temperature and burn attribute to VDB, inject them to the Pyro Solver. In the Pyro Solver, we have 0.3 as a buoyancy scale, in the flame 0.5 as a lifespan. In the shape, I use just disturbance with 10. In the other side, we have some simple object as a collision show. Because we have animated collision object here, we need to change collider frame range here as well. And here is the result. So simple. About the shading, it's pretty much same as the shader which I made at the beginning of this tutorial. This kind of the ramp as a fire intensity ramp and no smoke. The next one is about generating fire and smoke from different objects. Here we have simple truss with 45-degree around rotation Z, 4 and 4 as rows and columns. Same here with 0 rotation. We have some point inside the torus here, and same here. And also I keep the actual object of the torus inside geo group for both sides, because later on in the rendering we are going to render actual objects. Merge them together with simple animation with these two transform nodes. And one more animation here for both objects. I use trail sub to generate velocity. We have split sub to extract actual objects and the points. At this side we have just points which are useful for simulation, and here we have actual objects which are useful for rendering. We have another split sub to extract inside and outside objects. About the outside, we are going to have just density and temperature, because we want to just simulate smoke from outside object. But for the inside object we have temperature and burn, because we need to have fire for inside object. Convert those attributes to VDB for both sides. Now we have two different temperature and velocity from each side. In this VDB combine, I just combined the temperature from this side to this side. And same for velocity, set operation to add. Now we have just one velocity and temperature. Here we have density which comes from the outside object, and merge it to this side of the graph. Finally, we have burn, temperature, velocity, and density, and inject them to Pyro Solver. Inside the Pyro Solver, we have 0.5 as a buoyancy scale, 0.5 as a flame lifespan. I used dissipation and disturbance. And in the sourcing, this is our frame range, and we are going to use density, burn, temperature, and velocity. About the shader is same as our fire shader, which we had before, but you need to turn on smoke part here as well, because in this case we have both fire and smoke simulation. And finally, the last project is Skullfire. Its setup is the same as spreading fire, which we had before. We have simple object of the skull. Move it to center of the origin and scale it up a little bit. I painted the back of the skull because I wanted to have fire only from the back, not in the front of the skull. So I've used attribute paint sub and set the attribute type to the color. And we are scattering some points based on that CD attribute. Here is our active group. Make it white and other points to black with same setup of the growing effect. Make them a little faster. In this case, I've used just time shift, not retime. But there is no difference. And here is the result of the growing effect. Remove black points. And with this point velocity, I add some curl noise to the velocity. We have Pyro source to generate temperature and burn attributes, convert them to VDB, burn temperature and velocity, and use them inside the Pyro Solver. In the Pyro Solver, we have 0.5 as a buoyancy scale and 0.5 as a time scale. If the speed of the fire looks a little slow here, you can just increase the time scale to, for example, 1. In the flames, we have 0.3 as a lifespan, and also we are simulating some smoke during the simulation time, same for temperature. And in the shape, we are using both disturbance and turbulence, and 0.1 as a dissipation. In the other side, we are using the skull object as a collision object as well. And here is the final result. With exactly same shader here. And in this project, I decided to use a little low density smoke as well, not just fire. And once you have smoke and fire, you can play with the scatter part as well. And I forgot to mention that for fire thrower project, beside of the disturbance here, I've used two different micro solver inside force network, two different gas turbulence with different swirl size. And don't forget, with working with the minimal OpenCL solver, you must turn on use OpenCL in the advanced tab. For a skull project, as you see some frames, we have some sparks. And it's just very simple particle system. Let me show you. Sparks render. I've got skull model here and painted mask attribute. Exactly where we have fire. point velocity to add curl noise to the velocity, and pop network. I just use the default pop network here with very low amount of the particles. I just use 2.5 as a constant birth rate and very low lifespan and a little variance, and two simple pop force, one pop wind to add some turbulence noise to the velocity of the particles, and pop drag with a 0.5 as an air resistance, and of course the actual object of the skull as a collision object. And here is just a simple point VAP network to get age and lifespan, set the range and use it as the input of the RAM parameter. And here is the color of the points. We have some particles which their color is changing from yellow to black based on the lifespan. And attribute randomize to add some random value as a P scale of the particles. That's pretty much it. It was the last part of this series about PyroFX in Houdini 18.5 for beginners. I hope this series has been useful for you. In future, I will publish more advanced tutorial about dynamic and simulation in the Houdini. Thanks for watching this tutorial and see you in the next one.